84% of credential attacks now hit APIs, and you're probably paying for it. This is part 1 of our 2026 video report, The Broken Economy of API Dependency. Over 3 parts, we're exposing the hidden costs and data risks of third-party AI APIs. By the end of this video, you'll have a concrete audit checklist to stop the bleeding. Let's get into it. In 2026, 84% of credential stuffing attacks now target APIs, not web login pages, APIs. That's the headline from Radware's latest report. So if your applications, your data, your entire job run on APIs, ask yourself, how secure are you right now? And it's not just a security problem. It's a full-blown broken economy of cost, control, and survival. Let's get into it. Here's a dangerous gap. A 2026 survey by KongHQ found that 65% of organizations already generate revenue directly from APIs, yet only 25% operate as fully API first, and just 24% design their APIs for AI agents. Think about that. You're cashing checks from API traffic, but you haven't built the foundation to manage AI-driven dependencies. That gap isn't just bad architecture, it's a ticking financial bomb. On the left, the promise. A pilot with a budget model, low token usage, maybe a few $100s a month. On the right, the reality. Costs explode because pricing structures are complex and hidden fees multiply. Only 25% of organizations are fully API first. That gap leads to budget surprises. Don't let the illusion catch you. Now, to understand why costs blow up, you need to understand tokens. A token is a chunk of text an LLM processes. When you send a prompt, the model breaks it into input tokens. Then it generates a response measured in output tokens. Here's the trap. Output tokens typically cost more than input tokens on many pricing plans. So while your prompt was cheap, that long explanation you got is the expensive part. And many beginners think the cost is just per request. They miss that most of their bill can come from the model's own words, not their prompt. The numbers tell the story. 83% of organizations have adopted some level of an API-first approach, but only 25% are fully committed. That gap is where hidden costs and security risks live. If your team hasn't audited its API dependencies, you're likely in the 75% that's bleeding money. Now let's see how agentic workflows turn this into a fire. A typical complex query might have a large input context, already not cheap. Then the model enters a reasoning chain, generating internal tokens you also pay for. And it spits out a massive response, often far longer than the input. Because output tokens typically cost more, that one request can be expensive. A coding agent might repeat this process dozens of times per task, and costs escalate fast. So if you're building agents and you're not watching token burn, your budget is already on fire. There's another trap. Pricing isn't always flat per token across the whole conversation. Some providers charge extra for extremely long context windows. If your application keeps a long conversation history or loads a huge code base into context, you could be paying a premium just to hold the model's attention. This punishes any long-running task, from document analysis to AI coding, making costs unpredictable and steep. The common mistake? Assuming that more context is always free, always check the provider's rate card for context-length pricing before building long-running apps. API providers don't want you to scale for free. They enforce rate limits to ration their limited compute. It's not just requests per minute. There may be caps on tokens processed per minute too. When your app grows, you slam into these caps and get throttled. Even on a paid tier, dynamic throttling based on system load can hit you with no warning. Your production performance becomes unpredictable, and scaling feels like pushing a boulder uphill. A common mistake is assuming that paying means unlimited. Always study the provider's official documentation for exact limits and monitoring. Real-world reality. APIs are a moving target. Providers can change pricing or quotas at any time, and free tiers may shrink without notice. Without monitoring, your app could break overnight. The lesson? You're at the mercy of the provider. Set up usage alerts and monitor your API consumption daily to catch quota changes before they cause outages. Agentic AI doesn't just answer, it loops. Every cycle of perceive, reason, act, and observe generates many more tokens than a simple request. Even internal reasoning steps add to the token count, inflating your bill. One debugging session can quickly become far more expensive than you budgeted, because the model thinks through the problem step by step and you pay for every token. Some advanced models use extra reasoning tokens that are billed, making a single complex query surprisingly pricey. Across a team running hundreds of agentic tasks, these hidden costs silently break budgets. Always test your agent's actual token consumption in a sandbox before production and review the provider's pricing model for any hidden output costs. Before we move on, here's what you should now know about API costs. Model choice can swing your bill by an order of magnitude. Output tokens are always the hidden expense, and agentic loops burn cash quietly. The most common mistake? Projecting costs from a small pilot. That's how teams get surprised by five-figure bills. But here's the hidden risk. Every API call can send your proprietary code, customer data, and business logic to someone else's server. Some providers' terms may permit them to use that data for model improvement. Always read the fine print. Always audit the data usage policies of your API providers and consider self-hosted models for sensitive workloads. Here's the data flow. Your prompts, source code, and customer PII travel from your app to the API provider's logs, where they're stored, reviewed, and, often, used to train the next model. Most providers' default policies allow this. You're not just paying for tokens. You're donating your intellectual property. Mitigate by encrypting sensitive prompts and exploring isolated deployment options. Many AI services retain conversation logs and may use them for model training unless you toggle off data sharing. Don't assume an enterprise plan automatically protects you. Always verify your provider's current data usage policy. That's a 30-second audit that can prevent your proprietary data from being fed into the next public model. The 2026 API Threat Stats Report ranked API credential leaks as the second most common root cause of breaches. One compromised API key can unlock access to months of your team's AI interactions, potentially exposing proprietary strategy, financial projections, and pre-release roadmaps. Rotate your keys and monitor for leaks. The blast radius of a single breach is enormous. The EU Data Act now forces certain organizations to provide APIs for data access and portability. Meanwhile, many US-based cloud providers operate under legal obligations that may conflict. Embedding an AI API call that crosses these jurisdictions can create data sovereignty risks. Before you integrate, verify that your provider can satisfy both regimes. Otherwise, you're sitting on a compliance time bomb. Shadow AI is a real and growing threat. Employees are pasting proprietary code, customer data, and strategic plans into public chatbots. That bypasses every IT control and voids data protection agreements. The fix isn't banning AI. It's deploying sanctioned tools with data loss prevention. This week, audit which AI web apps are being accessed, and deploy a DLP solution that monitors for sensitive data leaving your network. Picture this. A developer's InfoStealer-infected laptop siphons their ChatGPT credentials. Suddenly, 3 months of code reviews, featuring a proprietary algorithm, are in a criminal's hands. That's the irreversible damage. Once APIs leak your business logic, there's no undo button. Your data isn't just conversation history. It's your competitive advantage, exposed. Immediately enable multi-factor authentication on all AI platform accounts and review login activity for those services this week. It takes 5 minutes to secure what could cost months of work. Let's lock in the key data sovereignty takeaways. Number 1. Every major AI provider logs your conversations and may use them to improve models unless you explicitly opt out. And corporate plans rarely change that. Number 2. Stolen credentials for AI platforms are increasingly common, meaning entire conversation histories, code reviews, financial projections, proprietary algorithms could end up in an attacker's hands. And number 3. If you're using a US-based API, US legal demands could force that company to hand over your European customer data, potentially violating GDPR, a classic sovereignty collision. The common mistake is believing your enterprise plan shields you from these risks. It doesn't. Sovereign AI is the ability to develop, deploy, and control AI capabilities entirely within your own trust boundary, so that no third party can access your data, throttle your performance, or dictate your compliance posture. In 2026, it's not just a government talking point. Regulated industries like finance, healthcare, and defense are making it a business necessity because a public API often can't satisfy strict data residency and audit requirements. Your concrete step: sit down with your security team this week and map every data flow that currently touches a third-party LLM API. That list will tell you exactly where sovereignty gaps are costing you legal exposure. The economics depend heavily on your model and provider, but at scale, self-hosting can flip the script. At a certain token volume, the per-token cost of running your own GPUs can drop below the price you'd pay for API calls. The break-even point varies widely based on hardware, workload, and provider pricing. So run your own numbers. Check current API pricing and hardware costs, and remember hidden costs like engineering time and data egress. The break-even chart only counts token costs. In reality, self-hosting adds salaries for ML engineers, time lost on manual model updates, security patching, and a noticeable jump in electricity and cooling. A common beginner trap is comparing raw GPU rental against API invoices and declaring victory. Those unaccounted overheads can push the true break-even significantly higher. The only way to know your real total cost of ownership is to run a controlled pilot with a modern open-weight model, like a recent Llama or Mistral variant, for 30 days and meter every expense. That's your concrete step this month. If you can't go fully on-premises yet, a private cloud instance, such as Azure OpenAI on dedicated capacity inside your virtual network, keeps prompts off the public multi-tenant endpoint. This lets you check boxes for data residency and audit logs, but you'll pay a premium for that isolation. For organizations that need the fastest path to regulatory approval without buying hardware, this is the pragmatic first move. Here's the pure on-prem flow. A user request hits an internal server running a capable open-weight model, such as a recent Llama or Mistral variant, and the response never traverses a public network. Data sovereignty is absolute. The common mistake is assuming open weight means slow. Modern quantized and optimized models run efficiently on enterprise hardware. If your legal team demands zero data egress, this is the model you need to seriously evaluate. For the highest sensitivity, think defense research, genomic data, or core algorithmic IP. An air-gapped environment isolates systems completely, with all updates and data transfers tightly controlled offline. The operational overhead is significant, but for contexts where a data leak could mean legal or national security breach, it's the only acceptable answer. Your step: list your 3 most sensitive AI workloads and ask whether a public API or even a private cloud would withstand a data sovereignty audit. If not, air-gapped is the benchmark you build toward. Sovereign AI isn't a solo sport. Governments and industries are exploring federated data infrastructures that let organizations share datasets under strict sovereignty rules without ever pushing data into foreign hyperscalers. It's essentially the operating system for a post-API data economy. For IT professionals, this is the long-term career signal. Knowing how to wire AI pipelines into sovereign data spaces will be as valuable as knowing Kubernetes was 5 years ago. Look for upcoming European Cloud Initiative documentation. Links will be in the description. Infrastructure independence boils down to 3 truths. First, the break-even on self-hosting is real, but only if you account for the full operational cost, not just GPU rental. Second, the 3 deployment models, private cloud, on-prem, and air-gapped, are tools in a kit, not competitors. Match the model to the data sensitivity. Third, sovereign AI ecosystems aren't science fiction. Gaia X and similar projects are already laying the regulatory and technical rails. The mistake to avoid is assuming buying a couple of GPUs solves this permanently. We've mapped the broken economy of API dependency in 2026 across 3 pillars. Pillar 1, uncontrolled token costs, output pricing that can be extremely expensive and rate limits that can throttle your production app overnight. Pillar 2, impossible compliance, Your data training a competitor's model by default, stolen keys exposing entire code bases, and laws from 2 continents pulling you in opposite directions. Pillar 3. The urgent shift to infrastructure independence. Private cloud, on-prem, and sovereign ecosystems aren't just options. They're becoming the baseline for any serious enterprise. In 2026, infrastructure independence stopped being optional. In the next part of this series, we'll walk through your first step, the API dependency audit that tells you exactly where your biggest exposure sits and what to fix first. The biggest mistake IT pros make when facing exploding API costs is trying to solve everything at once. The real first move is brutally simple. Audit every single AI API your team touches. Start by inventorying every endpoint. Yes, even the free Tier 1 Bob from sales used once. Those are the ones that suddenly break when provider quotas shift. Next, read the data usage policies. Many providers train on your prompts by default. If you're pasting customer data or proprietary code, that's a compliance time bomb. Then, project your costs. A 10x scale-up from a pilot can turn a $300 bill into $30,000 overnight. Finally, pull a small open-weight model with Allama on your own machine. It'll give you a tangible sense of what self-hosting actually feels like, and prove the concept in under an hour. Here's your independent starter kit. Small open-weight models like Mistral, Llama 3, and Gemma run on a single GPU. Check the model cards for VRAM requirements for your chosen size. DeepSeek's latest models are competitive but demand more VRAM and careful consideration of data handling policies. Hold these decisions against a benchmark like the Hugging Face Open LLM leaderboard so you have real comparative performance data. The tool that ties it all together is Allama. With a single command, you pull and run a model just like a Docker image. For scale and production, swap to VLLM. It gives you an OpenAI-compatible API without touching a hyperscaler. Start tonight. Install Allama, pull a current small model, and send a request. You'll have a private LLM running before the next episode of whatever you're binging. Let's stamp out the 3 mental traps that keep IT teams stuck in the API dependency hamster wheel. First, those free credits feel generous until you realize they're limited. A single agentic workflow can burn through them in under an hour. And then the real meter starts. Second, that checkbox you skipped during sign-up? It probably gave the vendor the right to train on your prompts. If you've pasted customer records or proprietary architecture plans into a chat window, that data might already be baked into the next model release. Third, self-hosting isn't a luxury reserved for Google or the military. A desktop with a mid-range NVIDIA card and Allama can run a 7B model right now. The barrier isn't hardware. It's the assumption that independence is too hard. In future parts of this series, we'll move from diagnosis to surgery. I'll show you concrete migration blueprints that swap OpenAI endpoints for self-hosted stacks, piece by piece, without breaking production. We'll set up federated data governance so your models never send raw PII outside your network, even when multiple teams share the same cluster. And we'll map out the career pivot most IT pros don't see coming. AI infrastructure specialist, the person who designs these internal AI factories, not just consumes them. Those roles are appearing faster than anyone predicted, and the people who understand both hardware and policy will write their own ticket. Before you go, download the API dependency audit checklist from the description. It walks you through identifying your biggest exposure in under 30 minutes, with practical steps you can take this week. That's part 1 of the broken economy of API dependency. Subscribe and hit the bell so you don't miss part 2. Practical steps to AI infrastructure independence, where we'll put these audits into action and build your first self-hosted LLM endpoint you can actually trust. In the meantime, drop a comment. What's the most shocking API bill or data policy clause you've stumbled on? The stories in the last video were wild, and I want to feature the best ones next time. See you in the next one.